Welcome to my little demo showcasing my DDA-5005, aka Wavemaster 8500 oscilloscope from Lecroy. This is a 5 GHz analog bandwidth, 20 gigasamples per second monster with 4 channels, and pretty awesome. This was a DDA version, so a disk drive analyzer version of the oscilloscope, but it has been modded to the standard Wavemaster series oscilloscopes. All the options have been enabled, all the sensible options that is. And the mainboard has been changed from a old Pentium industrial mainboard to a completely new mainboard with DDR3 memory and an Intel 2600 i7 processor, which makes this thing way faster. Also, the display now is a modern, much more modern, high resolution LCD. Here you can see the bezels because it didn't properly fit, but looks quite nice. Clear giveaways are the USB ports in the front, which the original doesn't have. It has a CD drive, so the USB ports make it much more useful. Then in the front you see it has only 50 ohm inputs, which are BMP plugs, which are quite special RF plugs, and the adapters are quite expensive. So I 3D printed my own versions of them, and then I used BMP to SMA adapters. The adapters alone cost about $50, but still way cheaper than the originals. Here in this demo, I use a Siglent arbitrary waveform generator, which also has been upgraded to 120 megahertz. Operation: channel 1 is connected to channel 2 on the oscilloscope, and channel 2 to channel 4. I show you only the picture of it because I connect via remote, which is much simpler to capture with OBS, and I hope much clearer than if I film the display. So let's switch to the remote display. Here we see we've already channel 2 already set up. This is a 120 megahertz sine wave, 100 millivolt peak. First thing I usually do is I go and recall the defaults, which brings up channel 1. We don't need channel 1. Go to channel 2. We can scale that a bit. See, 1, 2, 3, 4, 5. That's about 100 millivolt peak. You can see you have bandwidth settings. You see you only have 50 ohm and ground as your input options. The maximum full scale input is 5 volt peak, which makes it quite interesting. So the front end is rather delicate. Don't connect the 50 volt signal to it, or you will burn out the ADCs for sure. Probe attenuation stuff. You can do averaging, you can do interpolation, etc. Next thing we should probably do is go and set up the trigger. Change that to channel 2. So signal much nicer. As you can see, we have lots and lots of options to trigger on our signal. We can adjust the level if we would want to. It's really quite nice to interface with it remotely. So the thing is, as I mentioned before, it's just a Windows 7 machine. And pretty nice specs. But the cool thing about this is that the Extreme software is just an application running on the OS, and a lot of the math functions are actually, or pretty much all of the math functions and processing is done on the Extreme software on the PC CPU. So since we upgraded it, it's the performance of the user interface and also the speed at which the math functions can be executed is much higher, which is very nice. And also because it's just a standard Windows 7, you can RDP into the box and just interface with the system via RDP, which makes it really nice to use. We also would have here, if we go here further to the triggering options, we also have software triggers. I haven't played around with it. In general, the instrument has so many functions, it's quite staggering, and I have not played around with half of the functions, I think. What else do we have? We have vertical setup. Oh, here we could enable channel 3 as well. This is channel 3. We only have very small pulses set up, I believe. So we could a bit longer. Yeah, on channel 2 I have pulses 25 megahertz repeating 100 millivolt peak with the shortest rise time 8.4 nanoseconds, I believe. But we don't see anything. Oh no, sorry, it's not on channel 3, it's actually on channel 5. Here we go. Can disable that one. Larger. If we want to see it clearly, we should trigger on channel 4. Here we go. Now those are our pulses. Make them smaller in order to show them better as individual pulses. Here we go. What else can we do? We can, of course, adjust our time base. We can increase the numbers of samples we want to save. We have a smart memory function, which we can use to set up a more flexible allocation of our memory. We could use fixed sampling rate. We have interesting. We have channel 2 and 4 enabled. Should actually get 20 megahertz. I don't know why we don't. Why don't we get 20 megahertz? Oh, well, it doesn't really matter for our application. So enable channel 4. Okay. What else do we have? We have display. We can set that up as different grids. This is pretty nice for math functions if you can have lots and lots of grids, so you can show different math functions on the grid. but I think dual grid is the most sensible at the moment. Now we go into the math functions, which Lecroy is really kind of famous for. And here, here we see it's absolutely crazy. The amount of math functions we have on this instrument is just nuts. We have the basic math functions, which I think every better oscilloscope has. We have some custom stuff we can do. Oh, we can do MATLAB filters directly on the scope. So of course, since it's a Windows 7, we can run MATLAB on the scope in parallel to the extreme firmware and just run our MATLAB stuff on it. I believe you have to install MATLAB though to actually use it. Pretty sure of that. You can do interpolations, you can do filters of all kind. A lot of the things are also play into, if you see here, for example, for the init function, a lot of it is also used if you want to look at digital buses and signals. You have frequency analysis. That's quite interesting. You have the FFT, which I think is pretty nice. Spectrograph. We could enable that, but we also have another feature which I will show you in a moment, which is a bit nicer, I think. We have mathematical functions of all kinds. Very nice. We can graph the stuff. We have the jitter analysis package. We have some other stuff, special math package. We have statistics, histogram. Okay, well, so lots and lots of things. And also you can have up to 8 math channels, which you can build your own complex math functions. You can use dual function. Or you can just build your own much more complex math functions with this thing. Really quite amazing. Analysis, custom DSO. I've not played around with it, but if I understand it correctly, you can set up some basic. You can basically set up little programs or scripts which just run and do analysis on signal, and then you can just start one of them and it will just run some little script and set up and measure directly without you having to set it up manually every time. Nice. We have signal test functions. These are Ethernet. We have QPSK analysis. Electrical telecom, no idea what that does. Ethernet testing. Base 1000. I'm not sure how useful it is for base 1000. I don't know. Because it's just 5 gigahertz. It should be enough though. As far as I know, base 1000 has 250 megahertz actual bandwidth, so should be fine. We have serial data. This stuff. This is actually, I believe, Lecroy does a Wavemaster 8500 with the general purpose oscilloscope, the DDA 5005, which is the same, but the disk drive analyzer for HDD hard disks to analyze them. And then they also did a SDA variant, which had some little differences in the front panel, but was otherwise pretty much the same. And it looks like to me that you could use pretty much all of the functions of the SDA as well. Although I've not really used it much so far. Yeah, AI diagrams, jitter analysis, and a lot of stuff. Then you have the drive analysis, which this instrument was really built for. I don't think that has much use today. Then we have some power measurement stuff. Here you would need some current probes. I've played around with it a little bit with some non-Lecroy current probes, pretty nice. We have the serial decode functions. This is just great. Here are all the different protocols you could decode. So here, of course, your SPI, your UART, your what else? Standard CAN bus is quite standard. I squared C, of course, LS232, which is basically UART. We have, well, that's about all for the usual things, but then we have really esoterics. We have advanced stuff like USB, USB 3. We have DDA-5. I'm not sure how useful this instrument is for DDA-5, just because of the bandwidth of that stuff. 10G Ethernet. No, I don't think so. But we could decode it. The option is here. Just don't think this instrument is capable of it. We have some really interesting bus like 64B, 66B, and which are military aerospace kinds of buses. We have space wire, which is, as far as I know, a protocol used in satellites. PCIe. Yeah, it's a ton. It's an absolute ton of options you have. You can directly decode it. Graph. Well, yeah, I modded the instrument, but I used it very little so far. I also have a Wave Pro 7200, which I have modded similarly, which is just a 2 gigahertz analog bandwidth instrument. But it has standard BNC inputs and I believe 50 or 100 volt. Yeah, 100 volt maximum input rated inputs. It's just in general, it's a much more general purpose scope, which is more useful for daily usage. But this thing is a lot of fun as well. I just did not have much time to or much opportunity to really use it so far. Yeah, if specific USB 2 stuff, which you need some sort of fixture for. We have pass-fail analysis. Okay. Oh, here, this one is really fun. The spectrum analyzer. I probably will do a separate video just because it's such a cool function, I think. Let's go here to channel 2, enable interesting, why is it not showing up? Interesting. Normally, seem to have lost our inputs altogether. Why is that so? Let's go back, trigger channel 2, vertical channel 2, trace on. Probably because we enabled some sort of. Let's just quickly bring it back. Default. Get rid of that one. Set up that trigger for channel 2. Beautiful. A bit more. And now let's go back to spectrum analysis. Nice. Channel 2, please. Here we see the original signal. Think we can do. Can we do it? No, this is some sort of other. Can just set up the display, but let's get it to 100 megahertz and the span to. Actually, let's give it 250 megahertz and let's set the span to 500 megahertz so we see some of the harmonics. Ooh, could do variable span. Interesting. Resolution bandwidth. This is fun. Let's get it small, 1 kilohertz. And let's get the persistence off. So we see the update rate. Just use a normal rectangular window. And now this is fun. We can use, here's our waterfall diagram. We can use a fancy 3D diagram. I have no idea why one would want that. It looks kind of interesting. And it's really quite fast. So you see the update rate for 500 megahertz span, which is, yeah, we're doing an FFT on with a 500 megahertz span and 1 kilohertz of resolution. It is pretty fast. We can use peaks and have a table with the actual peaks. Of course, we have our signal at 120, 240, 480. That makes a lot of sense. 1, 2, 3 with the harmonics. All right. What else can we do? Oh, let's just disable this silly 3D diagram. Right, now here you see the waterfall diagram. And also, as I said, I probably will do a separate video showing the functions here a bit. Oh, let me just set up the interesting. Ah, here we go. Sorry, I'm just playing around with the frequency generator. Let's do let's do 50 megahertz. Ah, okay, I see the problem. So a carrier frequency at 100 megahertz and then a derivation of, can we do 20 megahertz? Yes, we can. Oh, look at that. So this is 100 megahertz carrier frequency, 20 megahertz derivation. Here we see the waterfall diagram. Here we see the little jump from 120 to 100, and here we see the modulated signal 40 megahertz wide, which I think is pretty nice. It's not as fast, of course, as a real-time, neither as fast or as accurate as a real-time spectrum analyzer, but for just a simple FFT function, I think it's rather nice. Oh, what else do we have here? Quick look at the utilities. There's not that much. Touch calibration. Yeah, well, software options. There are so many. Can't even show it. The name here is the wrong one. As I said, I have two identical. See, I have not adjusted that yet. We have an auxiliary output, which we can use for some calibration stuff. 1 megahertz. Unfortunately, it only goes to 5 megahertz, but you can use it to trigger. You can output the DC level, you can output the trickle enable, you can have a hardware pass fail output, date and time. Yeah, that's boring. Here are the software options. Problem again is there are so many, you can't show them all. Oh, actually you can. Okay. Okay, actually you can. Well, here you go. You can. These are the ones I have enabled on this instrument. Now, okay, that's pretty much it. If you have specific questions or things I could show with the instruments, then please ask in the comments below. I probably will do some additional demonstration on the spectrum analysis, but that could take a while. Thanks for watching, and I hope it was interesting. Bye.